Okay.
Yes, as I was saying, I was one of the computer scientists like coding and all of those things. And for real, it was hard for me to kind of talk with people coming from the different like backgrounds. And so I will try to kind of talk with you guys at the same, like with your language, with your like keywords that you are kind of very similar to. But before starting, I want to say what you're going through in this session. So we will try to get in touch, like to understand very, very basic things that I think it is kind of required for you guys to know about. I mean, current situation like generative AI and lots of these big words like ChatGPT, Cloudy, and all of it that they say, okay, everything is done. So I will try to first like kind of give you some idea, and then again we will do high level coding, high level like we will see high level coding scenarios that I think it would be kind of useful for you guys to use in your research. So it was when it was 2017 that one paper came out, and attention is all you need. And after that, everything got changed. Everything got changed. I mean, we saw like very early versions of the AI like afterwards. And like in 2024, like we saw like ChatGPT, like GPT-2, that it was like a preschooler that was able to talk with us, that was able to, say fancy words, and we were like, oh my God, this is going crazy like her. So, but what's the fuss about? So what is happening? Simple. I say any model, any LLM you see over there is nothing but just some multiplications and some summation. That's it. I'm not asking you to understand anything about it here, okay? It's just some mathematical formula, imagine. You give input, you get output. That's it. Okay, cool. And but the thing is, we deal with text data, we deal with images, right? But only computers and these formulas only understand math. How can I, for example, multiply pi with, I don't know, pi? How can I do it? How can I pass these text thingies or even images with something else? How can I do it? So that is why we need some representation. Look at the word represent. I want to represent this. I want to represent this word, okay, in a mathematical way. So to do so, like early versions, we came to the, I don't know, when we want to kind of represent a document, we were using TF-IDF, time frequencies, and all of those things, right? So, but what about LLMs? What is the thing about them? So the same thing, but the way they are doing it is different. How? We use tokenization. So that is why we tokenize, for example, text. We split the text into small, units. Okay, I'm not saying word. It can be a word. It can be a sentence. It can be one character. I'm saying a unit of text. And then we like say, for example, let's say in Turkish or in, let's say this number I'm gonna say is just like a random number. We have, for example, 2,500, for example, units, unique units of text. Okay, just assume that. And how, like now, if I say Akıncı, I will say we're starting from zero. So starting from zero to like 2499. So we call we start like assigning these numbers to those units. For example, merhaba. Okay, I assign this, for example, 0. Okay, simple. I just assign unique numbers to each those teeny tiny units. So I'm moving from text to number. Okay, but these are just numbers. like 0, 1, 2, 3, 4, 5, 6, 7 until 2499, there are just some numerical numbers, but there is no relationship between those, right? There is no relationship between, for example, 0, let's say this is merhaba, and 1, for example, selam. It's just one number, incremental. So we say that, then let's do this. Let's come up with some vectors. Okay, let's learn a vector. Okay, let's learn a vector for each of these. Let's find certain vectors that if we do some linear algebra like operations over them, we would get some meaningful relationships between them. So for example, let's say if you want to do cosine similarity, if you remember from like İnanç Hoca's course, we were calculating a cosine similarity. It's just a dot product, and the value is between like -1 and 1. So when it is 1, it means they are completely similar. Okay, the vector of merhaba, if I do dot product with the vector of selam, it will be probably close to number 1. It means very similar. Okay, but what if something is like -1? -1 means that it doesn't mean that they are not similar. It means that meaning in the like it's like good and bad. It's just opposite of each other. There is a relationship between them, but it's just in the opposite direction. But what does it mean to be something 0, number 0? It means they are just independent from each other. Like there is no relationship between them, like merhaba and araba. What's the relationship between them? Nothing. So we want to come to a world with those vectors that if I do such kind of arithmetic operations, I would get such kind of meaningful scores. Okay, so this is the whole idea that deep learning let us do that. Okay, in the deep learning, we provided the input, we provided the output, we said learn. You'll know what kind of vectors you should come up with for me, that if I do such kind of operations, I will get a meaningful output. So let's go to basically here. So this is a place on Hugging Face, okay? And it's just a playground. You can put any random text here, okay? It tokenizes us, like it does the tokenization. For example, it uses GPT-4 tokenizer, okay? Once upon a time, there was a day that computer scientists were coding a lot. Nowadays, we are vibing, okay? And you see, for example, for this part, it came with this unit. I'm not saying again a word, but it breaks down the whole sentence to multiple units. So once upon a time, blah, blah, blah. And at the end of the day, it becomes 20 to 27 tokens. Okay, why is that important? Why we need to know how many tokens we have? Because we have some limitations. You may have heard input length, context size. You may have seen these in the all the advertisement of the OpenAI. Like we have this context size of 1 million. We have this much blah blah blah. It means that they have a model that you can give, for example, token 0, token 1, blah blah blah, token n. You can give n tokens at most. Okay. So before, for example, we were able to give, let's say when models were small, we were able to give, for example, 1 page of a book. Now you open Cloudy, you put the book there, ask question, because the input or the context size is big. So now here there's a button, token IDs. These are basically those like incremental numbers, 0, 1, 2, 3, 4, 5, 6, I said. Like mapping. So for example, for ones, the corresponding number is 12805.
Who decides what the token ID is?
So
Is it a secret society that?
No. The thing is, we train even the tokenizer itself. There is no important thing about like if I assign this to that or what, okay? The only thing important is we have to assign this because there is a table in the model. Okay. Starting from 0 to let's say vocab size. Okay. And for each of these, there's a corresponding vector. So when I come to 12805, I will look at, okay, here's the 12, like, what's that? 805. I'm getting the vector of.
Sorry, so they're actually randomly assigned
In the beginning,
identifiers.
in the beginning, yes.
In the beginning, yeah.
But once we train the model on the objective, like in the objective of these generative models is just predict the next token. It learns what those random numbers change to.
But
So
these are
that-
identifiers, right?
Sorry?
Identifiers.
These identifiers?
Yeah. The numbers are the identifiers of the words.
Yes.
Right?
But no, it's like if we have king minus queen, it's equal to man minus queen.
That is the analogy that we are able to do once we learn a model. I will come to that.
So there are different tokenizers like algorithms, right? So word piercer and others. So
DPE and
yes, what? Yes, what? I mean, does it matter?
Yes.
Tokenizers. So for instance, why are the difference like why GPT is using this tokenizer but not others?
So first of all, there's a difference between the algorithm and there's another difference between the models tokenized. So for example, you can find two models. They're using the algorithmically speaking, same kind of algorithm, but that doesn't mean that they're tokenized like same. Because they have been trained separately. In terms of the algorithm, like byte pair encoding is one of them. Okay. And or word piece. So let me give you an example. Okay, let's say BPE, let me just give you an example. In English, character T, character H are the most concurrent like pairs of characters that happen to be next to each other. Okay. So you're saying like let's start this graph like from naive scenario. If I start like if I just assign how many characters we have in English? 30, is it, I don't know, 32 whatsoever. If I just assign, let's say my vocabulary set is just characters, 0, 1, 2, 3, 4. Just assigning for characters. It is like asking then this table would be very small. And it will be too much to ask the model to learn like a kind of representation for the character that would be amazing for every kind of scenarios. So let's say you have 32 characters. Then I count the two occurrences, TH. I see that and then I rank them. Then I assign a new index for that, 33 for T and H. Then I go incrementally, and at the end of the day, it becomes a graph. Okay. So this algorithm is BPE. Okay. There's another one that word piece. It splits on spaces between the words. It understands like it doesn't mean that, for example, conversation. So word for word piece would be converse. Okay, to the sign, for example, index 105. And shen, like 10, for example, 6. So it would split on the word border. But does it matter? Yes. Like for languages like Turkish, that's one word can be a sentence. Okay. And like morphologically, it is very, very complex. With compared to the English, sometimes it's good to, for example, use byte pair encoding with certain adaptation that they do. There are papers on top of it. This is just a choice by the designer what kind of tokenizer they're going to use. But at the end of the day, for each model, you should choose the corresponding tokenizer of the model. Otherwise, because, for example, in GPT 4, for converse, you can get 105 index. But let's say, I don't know, in Llama, you could get 2. So the representation in that table would be different. So there will be mismatch. I hope I could say it. I could like convey what I wanted to say.
As social scientists, should we care about this?
What social scientists should know is use the tokenizer of the model you are using. That's it. But know how many tokens you have, because you have you should know you have some limitations. The cost I will talk also at next in the next parts. But before going to start into everything, I want to introduce you a resource of that Akın Hoca should also a little bit insist take notes. Google Cloud for Research. So you can apply for this. This is for PhD students, for researchers, that they give you $5,000 if your proposal is approved. So you will get to massive amount of infrastructure that you can use any kind of the model, third-party models with API easily. Okay. For doing so, you come to this web page and you should write a proposal on what kind of research you're doing, and in a week they get back to you. So it's just something that kind of cool to have. Next thing is, I ask you all, please go to this web page right now, aistudio.google.com. We want to get an API key for Gemini. So we need that to run the codes all together. I am zooming a little bit, maybe it doesn't zoom there.
So we go to the new app.
Yeah, so you go to Google AI Studio. Then here there is a key button, bottom left, get API key. Then you need to create API key top right.
Default Gemini.
Yeah. This is the free tier, so you do not pay anything for it.
See, this is very important.
Yes. And once you create it, there is this copy button. So you please copy that. And then we are going to start the lecture now. How much time? Yep, 20 minutes.
These slides,
Sure.
that's somehow now come close to these slides.
Yeah.
Not all of it, just these one. Yeah,
Perfect. Thank you. Yeah, we are going to that. So that's there because you can insert your billing information. And once you insert, you may have different projects. So you may create different API keys for each project to have a more control. But here we are just doing some inferences. So for you guys, it's enough. You may get some quota limits, like when you're running the codes. It says 50 seconds, so you should wait a little bit and rerun the code. So in the drive that I shared to you guys, there are 3 notebooks. I am going with the first one. So in the whole part of the project, I will use light LM package of Python. Okay, you can use LLMR or something like that. I don't know how to pronounce it correctly. But the whole concept is the same. Okay, you will have API keys, and then I will walk you through the whole thing. So as I mentioned, what all of these models are doing is basically next token generation. Okay, for example, the cat sat on the what? Like we are asking it.
Just in case they can't follow, so this is the Python file in the Google Drive that we sent you, opened up on Colab, just in
Yes,
case. you don't-
yes. So when we are training the language models, we are just asking, saying that we provide, for example, first 4 words, and then asking like, tell me what is the most probable word, token, unit of text that if I put it here, it would make sense. So this is the whole idea. Okay, next, token prediction. So you remember this random number, 2,500? Each model has a different vocabulary size, okay? You can, then one may ask, how would I know what is the vocabulary size of my model? Okay, like for example, you can open huggingface.co. Here, you would go to the model section. Let's search for example, let me put it down here, llama. This is Facebook's basically model. In the files and versions, you click on this. If you scroll down, you would see this config.json file. This is the configuration information of the whole model. If you click on it, you would see this vocab size. So for llama, it is 128,000. Okay. And it is multilingual, by the way. So it's kind of a arbitrary number that the trainer chose based on some instincts. We don't know what is the amazing number that if we put it there, it would be enough for us. Okay, cool. Let's get back. So upon prediction, so when I'm asking the model, hey, the cat sat under what? It gives me probability for each of those vocabularies. Imagine something like this: mat, floor, chair, roof, bed. Like there are a lot of massive number of words in my or tokens in my vocabulary set. Okay, for each of them, it assigns a probability. For example, for mat, it is 42%. Okay. Okay, I got this output. Does it mean that I should put math here in the time of the prediction? You can, but it would be greedy. It means whatever model is confident about, I'm gonna put it in my, in the time of the prediction. Is it like the only thing you do? Or I can sample. I can do weighted sampling, okay? Why we are not doing greedy moves? Because a model can make a mistake, okay? A model can put a wrong word over there, then whatever comes after would be again wrong. Imagine like this: a person who lies needs to lie and lie and lie to prove his previous lies. Okay? Clear? Is it clear for you guys? Okay, nice. So we do random sampling, but to do sampling, there are metrics. How are you going to sample? With what methodology and things like that? So there's a great story on top of it, but at the end of the day, they said, let's use nucleus sampling. I'm not going into details, but I'm gonna talk about only the parameters that they're quite important for you guys to know what you are setting over there, okay? One is temperature, top P and top K. So when a model gives me probabilities for each word, like for example, mat, bench, floor, for each of them, it assigns a probability. And this is top 0 to 1. The sum of whole should be 1. Of course, the sum of the probabilities is equal to 1. Okay, we know this from okay. What I can do is I can do sampling. What does sampling mean? It means that imagine you have a box of markers, red, blue, okay? But majority of them are blue. If I close my eyes and pick one, probably I will get blue, right? but there's a chance that I would get also red marker. It's good actually. Sometimes it is good. I will come to the times that we are saying sometimes. So this temperature does what? This temperature, for example, when a prediction is so strong, we can divide the whole values into something called an temperature to like how to say, to make that, to remove that kind of sharpness from the distribution of the whole probability. So let's start. We will see all of these in action. So before everything, you should install Light LLM and the Gemini, like Google Generative AI, Pydantic we come after, Pandas and Python.env, blah, blah, blah. So on Colab, if you put percentile pip install, it will install those things for you guys. So for instance, if I run this, it will install all of those. In your local machine, you can use UV pip install and blah, blah, or pip install normally. So it is installing. So if you got your API keys, okay, for the sake of simplicity, I'm just going to paste my API key over there. I have it here in my Obsidian. Okay, I just paste it over there. But normally you should create the environment file and read from over there. So you can right now copy and use, and that will cost money from. Okay, so let's run this. So we do some imports, and I am setting my environment Gemini API key. So if I run this, I'm good. Okay, cool. But before doing, I should know what kind of models I have access to on Gemini, on Google. So for doing that, once you install this generative AI module of Google, you can set your environment like this and then ask list models. Hey, tell me the models that you have, please. And then I'm just, and if there is a generative content, I want the models that they are generative. I don't want embedding models. And I'm asking, hey, please print them for me. And now I'm running. So there are a lot of models, 2.5 Flash, 2.5 Pro, blah, blah. Some of the models are preview version. Some of the models even understand image, for example, here it generates images. So you have option to choose any of them that you like. Here I'm using 2.5 Flash. Okay, because the free it is free for you guys, so you can run, and it is cheap for me, of course. So running this. Now I want to send the prompt in one sentence. What is the large language model? Okay. To doing that, first you should import Light LLM completion. Yes.
Let's see, is everyone here, did the previous codes work well? Can you follow?
Any questions? Yes. So let me scroll up. So you can paste it directly here. It's not a good practice, but you can.
It can, I run like
As
that.
you should install. Yeah. No, you should remove this sharp.
Oh,
It's okay. So we are installing dependencies. So for installing dependencies, you should remove this hashtag sharp, different names, and then run it.
I thought it was part.
Everyone cool? Everyone okay? Maybe you could look around. I think that in the effect is itself and or maybe you used beforehand, I don't know.
Who couldn't do this?
Hocam, so
No.
it's something for specific for him. Bu şey düşünme. Şey almışsın. Biraz bekleyelim.
Bedava kullanmışsınız.
Bir sitcom aynı bir yani sensör benzer bir şey.
Yani böyle sıfır konuşma dedi. O modeller insanlara fark ediyor.
Tamam.
Ben Allah'ın
Yani bugün konuşarak yaptık aslında yani farklı şeyler.
Swap yapmaz.
Böyle
Yapmaz.
zengin yani ben
Then, so it can be a third time. But how would you know there's no such thing? You should probably manage it. That's what I'm about. Sorry?
They're coming from different seeds, so the output is different. But if I set the seed, then I can get the same.
You can set a temperature to 0, you will get the certain output.
Oh.
Recent funding are showing that temperature is not an important variable. You should see.
Buradan söylüyorsun yani iyi
Program.
Yani olan böyle yapması lazım.
once it's installed, like and like because the key is something like you get all the time of the stuff. Here's I'm just doing the same thing, but it's all this one. Okay, guys, if everything is fine, let's continue. So here, first I import the package like LLM. From LLM, so there is this module completion. Okay, cool. Then you can call it in Python. If you want to call a function, you open parentheses in front of. Like basically, you do this completion. Oopsie, typo. Now I'm calling the function. Now I should pass parameters, arguments to it. What kind of calling? So look, when I didn't touch, the documentation is popping up. It is asking for model. So I should use which model? It asks, so what is your message? What is your prompt? What are you providing for me? So here, I set the model here to Gemini 2.5 Flash. By the way, you can replace that with Anthropic model, or you can use any model Azure, for example, providing. The same code, nothing is changing. Okay, it's just a model ID you should add the API key. That's all. So you set the model, cool. Now inside the messages, why we are saying messages? Because if you open, for example, Cloudy, Gemini, blah blah in website, okay, when you type a prompt, okay, you continue. Even this it was a ChatGPT problem actually. When you were continuing going on, somewhere it was lagging, right? Why? Because it was also passing your previous talks to the model. Okay. Your first prompt, the answer, first prompt, answer, all of it. So here, this is the initiation part. The first prompt I'm providing. So what it means is you can, for example, get the answer of this, add this to this list again, a new prompt, so you can increase the list of your messages. Okay, but of course, you're using tokens, money. So in this way, it would know your previous conversations, basically. So there is this role. So you have a list. Inside the list, you have dictionaries, okay, objects. I don't know what's the equivalent of that. So you should provide the roles. So what kind of roles we have? User, assistant, and system. 3. Okay. In system, if you've seen, you're a helpful assistant, blah blah blah, or you are a like machine learning engineer who knows everything about machine learning. That is your system prompt, or basically your instruction prompt. User prompt is you are the users. You provide the query. Assistant is the answer. The assistant is basically the answer of your model. So when I pass this, and
Right.
no, you should. Sorry.
System stage. We could just
That doesn't.
write.
And the
So
order should not change either, right?
there's like depends like a little bit. That's quickie. So I will get to this part. Okay, please don't rush. So you run this and then you get response. It's an object. It's like the output of the model it provides me. Let's run it. It is right now costing me some money. Cool. Answer is a large language model is an artificial intelligence model trained on immense amounts of text data to understand blah, blah, blah. Cool. So this was response in R. You put this $, then the whatever inside. Here we put dot. Here you are very simple people. We put dot and then choices. And then I'm grabbing the first item, the message, the content. So when I do that, I get this text. So what just happened? I am also printing these response usage prompt tokens, response usage completion tokens, response usage total tokens. it's like the prompt token was 12, my input, it was 12 tokens. For answering, it used 866 tokens, in total 878. Why this is important? Because for your research, you may require to calculate how much money I'm going to spend on my queries, okay? So before passing this, there are tokenizers. You can run on them and get how many tokens you have. Then you open, for example, OpenAI or Gemini website. There is this table that they say, hey, for 1 million tokens, it's going to cost this much dollar. Then you multiply this number, whatever you come up with, to that, then you understand how much money you're going to spend. So messages is a list of role content. Roles are usually system instructions to the model, as I said. User is your query, and assistant is the model's previous answer. So if I keep going on, it will be system user assistant kind of messages. So you can append and then keep the history on. So here I am defining a function named ask. Okay, I will use it later on a lot. To define that, I'm saying def ask in Python. You put def, comma, arbitrary name. You define your argument, system user temperature. Here I set the default temperature to 0.7. So if you don't provide any temperature, it will use that number. The logic inside is the same thing, completion. I'm giving the model messages. Look here, we have role is the system content, the system input. Role user content is the user input. Here, I also provide the temperature. Once you do that, you can use your function ask. For the system, you are a terse political scientist. Answer in less than 20 words. And the user queries what distinguishes populism from other political styles. And when I run it, it will answer like a political scientist. Future, for example, I don't know, I can make it. For example, like it is the answer. I'm not sure whether the answer is correct or not. Probably it is something close to whatever is really.
What if now you change the temperature?
Yeah, coming there. Like you see, the next section is temperature. Yes. So when the temperature is 0, here is the thing. When the temperature is 0, it means that I am going to be super greedy person. I'm going to use the most probable word that model is predicting. Okay. And why is this important? Because then we can generate in a deterministic setting. And why is that important? Because when you, let's say, write an article, a research, you say I used LLM, for example, to give me the, for example, I don't know, like summarize, for example, the web articles. And I believe I got, for example, these summaries, and then I did some analysis on top of these summaries. Okay, cool. And this is my result. The reviewer can ask, what was your temperature? Why is it important? Because if I want to replicate this whole thingy, okay, it should provide a deterministic summary. Like it should provide me something that wouldn't be very different from if I run it again, because it will change my outputs. It will change my analysis, right? For example, I don't want to write a creative summary for me for a news article. I want, something cool, deterministic. Then if I increase the temperature, it can be very creative. It can generate creative. Like why? Because when I increase the temperature, I give a chance to the other low probable vocabularies. Okay? So let's try. Name one fruit, reply with just the name, nothing else. So I'm setting 5 times, by the way, I'm generating. The temperature is 0. I'm using the ask. Let's run. Oopsie, I got rate limits. We need wait 59 seconds. Any questions?
And let's see what happens. But Christopher Barry told that if even we change the temperature, we can't replicate with LLMs. But
We can't.
we can't.
Yes, we can't replicate, but we want to be deterministic. The replication is different than being
We can
deterministic.
test it. We can increase temperature and see if anything changes.
Here, we set the system, yeah, okay, you're a political scientist.
By the way, it's another good thing to do, by the way. Go on.
Okay, so
Because it doesn't help at all. Like,
when we do it, no,
I know there is a paper that does say that when you are saying you are something like that, it does not, so what? Like kind of thing, okay? No, instead they say that they provide the task. Say you are going to do this, that. Don't say you're like blah, blah, blah, blah, blah. Because really it doesn't help. Like in my own research, I don't use.
okay, so now, we're being here now, here.
It's just an example. Okay, are we in a minute? No. Any other question?
So, sorry about asking too many questions.
No, no.
Instructions are really helpful, so I get excited. Is this distribution like multinomial logistic, something like that, or?
We don't know what is that actually because it's a black box. We don't know what is really model learning.
When you say temperature is 1.2, it says more flattened distribution.
Yes.
I was.
And when I am sampling, I'm using the Nicholas sampling method.
Okay.
It comes and chooses. So when you're flattening, it means you're given chance to do a low probability. In reality, low probability token, right?
Okay, but in terms of the standard statistical distribution functions, does it correspond to some particular type?
No.
So it's a distribution over categories, right? It's like after all words and they adapt to one. So
Yes,
like
yes, exactly.
It's called Richter distribution.
I don't know. You mean Drukle?
I don't know how to pronounce it.
So when we do LDA, it's latent Dirichlet allocation.
I see.
It's distribution. Yeah, it's like
It's just-
categories.
So it comes from here, that then you get the logics of the model. Logics is one step behind the time we are calculating those probabilities. Use softmax, like a function. It does this. E to the power of x divided by sum of e to the power of all the x's. Okay,
So the
so
is
everything becomes between like the line.
value of the temperature is that.
It is not a temperature. Temperature comes and
Yeah.
divides by compute.
Oh,
X over there is the logit. Again, I don't want to get into lots of linear algebra and things like that. So that's why I'm avoiding.
The word pressure is a new thing like LLMs.
It was, you mean new word? Sorry.
It's a new word for like an LLM. Or what is there any meaningful way of explanation for this? People choose temperature for law.
It is for so in the context of generating, generating something by LLMs. Okay, in this context. They're defined temperature, something a value that divides the whole logits of the outputs of the basic model by that number. Okay, and this changes the whole distribution we have here. So it flattens or it sharpens. And by understanding, by using it, we understood when we set to 0, it's like, honestly, we cannot set to 0 because here there's some small tiny numbers here. But we add this denominator. When we do that, it means I convert, imagine this was my main distribution without temperature like manipulation. With doing, it becomes like this. And this was math. So now if I sample, I will definitely get math, right? But if I increase it, so this was like say T0, that's just saying that. But if I increase it, this is mat, this is bench, this is floor. Let's say this is 3, more or less like, and the temperature is very high, let's say, everything becomes like that. So if I sample, I will also get the chance of using word floor. This is the ideal temperature. So let's run, let's see if it works. Please work. Okay. It's not, unfortunately. 24 seconds. But it generated one item. Yeah, look, I'm not running the rest. So I wanted to generate 5 times. I generated twice, and then in both times it provided me apple. Please help me and don't. Maybe I can generate another one, but this shouldn't be okay. But for this one, the temperature is 1.2. Okay, so I'm increasing the temperature at this moment. So I am trying to make the model to generate creative content, not always Apple. Okay. And if I run this, let's see what you permit. Yeah, this is the problem. Yeah, this is 0. No. Yeah, it's because
In any student's playground, you can also experiment without any, it to code something.
sorry.
And just change temperature and get result in AI Studio's playground.
Yeah, we can use that as well. Actually, I wanted to go to, I had it in mind. Let's go here. OpenAI Playground. You see it was already clicked. So OpenAI just provides this platform playground for us that we can generate content, for example. And GPT-5, I think we should change this to responses. Unfortunately, they removed that thingy, I guess. Like you can provide, for example, hi, it provides you the answer. It's just a playground that you get the output. And you can change your prompt and compare the output of your system. For example, I can compare this, okay, with a new one. How are you doing? So
how did we get here?
So you go to the platform openai.com here, or search for OpenAI Playground. Like you can change the model, for example, to something else. For example, GPT, there are a lot of models. Let's say GPT-4.1. And here, as you can see, good that I clicked on it, you see there is this temperature value, okay? So for example, I want to go to, let's say 1.6 and say, is there any save button here? So here you see that this is a scenario, but let me change this to GPT 5.5. But for this one, we do not have any like scenarios, but let's go GPT 4.1.
I think they have removed the temperature
Yeah.
option for reasoning models.
True. So I'm setting this to that. Okay. Okay. Hi. So the thing is, it is really hard to right now see like the effect of the temperature here because they have some sort of randomness inside. But on API calls, I'm 100% sure that affects a lot. But who is, for example, Barack? Is it correct, Barack Obama? I'm not sure. So this is who is Barack Obama text. It provided me this. I'm gonna ask one more time, who is Barack Obama? You see the content it is providing more or less very similar to the previous one at the left side, okay? But at the right side, when I am asking, it gets two outputs. So this is the output at the right side, high temperature Barack Obama, okay? One more time, a very different answer because the temperature was high. Let's get back, please work. Nope, rate limit. It's interesting, but I will continue because I have the answers and you can replicate definitely. So for classification, extraction, coding, I don't want to be creative in coding. Why? Let's say in Python, more or less the structure is similar, right? You always have def or plus or thing like that. The vocab size is very small. You want to be correct. In summarization, you may want to add a small amount of temperature, 0.2, 0.5. For brainstorming, you want creative ideas. What makes the things creative? To come up with some low qualities that hopefully in the future, I would get a very different content with a good meaning, with a good understanding. There's other two parameters, top P and top K. So why it is important? Again, in this distribution, okay, top K is basically before sampling, select the top K probable items, okay, sample among them, don't sample like among all of the vocab size. This is top K. And top P is basically, you start, for example, this is 0.2, this is 0.5, or not 5, 1. And this is like 0, 0, 5. So imagine my top P is 3, 0.4. I start to do sum these values, 0.2, 0.3, 0.335. So I go and select only that the cumulative sum of their probability is in that range. Otherwise, I throw out the rest. Then I sample. Okay, this is the idea of top K and top P. Any questions? Yes.
What's the situation if you were to matter to specify a top P versus top K?
You just use one of them. Sorry.
Is there a situation in which it would matter which one you use? To have
Yeah, I am very fond of top P. Yeah. So it is like the thing is, it's not like there is no theory behind of it that if you set to this, for example, it would be amazing. But it's just a matter of trying this. You need to try which one is working for the path the best and get the first. Okay. So let's get back to ask P. So this is the top P, like basically, again, I am redefining my ask function with ask P, okay. I have the prompt, I have the temperature, it is 1, top P is 1, okay. And the default value, and the same scenario, completion, model messages, and then I return the output, okay. So I have run this before because if I run, I will get the like output will be gone. So I'm not gonna run it. See the output. So let me try. Hopefully.
It's a daily rate as well.
Sorry. I can't hear. Can you?
I think we hit the daily rate.
Yes, I don't know. The thing is the billing. No, we didn't do that much. I didn't. I have also set my billing. Like it should work.
There's big limitation on each model. Maybe you are using state-of-the-art model.
No, even I have like this is no, it works vice versa. It means that you are not going to pay. You have already money in your pocket. So this is weird, like for real. But let's get back.
I have an open browser API key, I can share it with you and maybe you can use it.
Yeah, why not? Sure. If you are donating, I would be happy.
Yeah, I have limited it. It's just going to be
We already have the
$1.
output.
Yeah.
You have it? Okay, perfect. But let me go from this table. This is the goal of this previous one. So again, for brainstorming, you set the temperature high. The top P is also a high number. So it gives you maximum diversity, unexpected ideas. Okay. For email report generation, I hate the people who write their email with AI. Like low temperature, top P is very low. It's predictable. It is focused and conservative. For creative writing, again, temperature should be high, top P should be low. And for translation, we do not want that much creativity, low, and top P should be high. Okay. For code generation, low, of course. For classification, again, for the deterministic scenario, we set the temperature to 0. So, but by far, what was happening was you just provided some queries, you were getting some textual outputs. But what if I want to control my output structure? Okay, why is this important? Imagine this: you have another software, anything. Okay, it just accepts like in a specific format. Like it tells me like you should give me a JSON file that there is this key of sentiment, okay, and the value. It should be like this. I don't want anything like, I think it is positive. I believe it, this text should be positive. I feel that this text should be positive. There shouldn't be like that. It just should give me this JSON structured output. So for that, we say, okay, let's get a structured output from the model. Okay, let's ask the model to provide me the answer already in a structured scenario. So, like, look at this, for example. The system says you return only valid JSON, no commentary, no code fences. User asks, classify the sentiment of, I finally submitted the paper, feels great. Okay. Return sentiment positive or neutral or negative, and with some confidence number. And then I print, then it provides me really a text that has that structure. Then I can give this text to this JSON loads. Okay. It parses it and makes it a Python dictionary. Now, the thing you see here is a Python dictionary. It's an object, but this one here is just a text. It is hard to show in console, but this is what the fact. So what it means is you can use this JSON blah blah blah and put square brackets and say sentiment. It will give you the output. It will give you the real sentiment. But it is hard to control that. Then what? So what if it didn't provide me the structured output? What if I asked for a structured output, but it gave me something weird? What if that happened? So for that case, they created a great library, Pydantic. Okay, it validates the output of the model. Okay, and how we are going to do? I just define my output. How? We do some certain imports, of course, from Pydantic import base model and field. So my output, I am just given a random, like whatever you say, I'm saying sentiment. So if you know Python very well, when you put like parentheses and you put the base model, you are extending from the parent class. Okay, you inherit whatever base model has to your current class. And then you define your fields. I want sentiment, I want confidence, I want rationale. Why this was the output? We will come to this. This is very important for when we are trying to do prompt chaining. And then I say the possible outputs. I put literal, and inside literal I have positive, I have neutral, I have negative. For confidence, I'm saying, so when you put this colon and float, it means the type of it should be float. You can avoid that as well, by the way. You can remove this, doesn't matter. But this is important. It's a field greater equal to 0, less than equal 1. So you define your constraints. Again, completion, we give model, we give our system query, we give our user query, we give our temperature, and we give response format. Response format is nothing but basically the name of the class. Okay, and when you give that and when you run it, you can validate sentiment model validate JSON. Okay, it gets the output of the model, validates that this is correct, and gives me the object. Now I can, for example, say parsed dot sentiment, parsed dot something. It's a real object, so you can use it. Questions? Yeah, of course. Unfortunately, that's the case. Hocam, use some dollars.
We must ask to fail for money.
Why not?
So. Yeah, let's take a 15 and come back.
I feel it was heavy.
You already have,
Thing is, I didn't have a.
only for this.
I didn't
Yeah,
have that.
yeah.
That was bad. I hope we had it.
Yeah, we only have.
But the rest is fine.
We do,
Yeah, I'm sure it's fine.
yeah, it's fine. Türkçe mi İngilizce?
İngilizce. Technical şeyler de İngilizce.
Okay, validation, what do you mean by validation?
Model mesela ben istemiştim böyle dersin. Ne bileyim nasıl belirlenmiş mesela. O text alıyor.
It's the output format, but
Bak model günün sonu text generate ediyor değil mi?
yes.
Tamam. Ama benim Python'da object istiyorum.
Hı hı.
Dictionary mesela istiyorum.
Ha,
Ama dictionary yapmak için format text tam doğru olması lazım.
Ha.
Ama mesela benim düşünürken bunu belirlenmişti. Bu şey yoktu.
so it's the JSON format that.
Ha, mesela ama yanlış vermiş. O validate ediyor ki onlar doğru diyor
It's the
değil.
validation.
Ha.
When you say validation, I talk about, comparing against ground truth, but
Yeah.
it's not that, right?
Yeah, exactly. No, it's not that one.
Yes, okay.
Like for example,
It's about the output format, right?
yes.
Okay.
For example, here, you actually have only one of these and not this. I use those
Okay, okay.
because it is text at the end of the day.
Okay, okay.
So I have a question. So we give it a Python object and we give it like rationale, sentiment.
Those are the my expected outputs.
Yeah, so we want the LLM to
Fill in those lines.
those. And my question is when it is filling the confidence. And is it possible like they will hallucinate?
It is very possible.
Because when they are filling it, they are literally just predicting
Yeah,
the
it's
next
just the
word.
next
So
token.
it is not real reflection of how.
It is
confident
not
they are.
recommended to use. Yes.
Yeah, okay. Yeah, thanks for answering my question.
Yes.
No, you didn't.
Yes.
BP için konuşuyorum. Byte token. İlk başta hocam, we define a vocabulary set. We want to create a vocabulary. Okay. Okay. And we just come up with a number. Let's say I want a vocabulary set, maximum 15 nouns. And there is a huge amount of text data, right? So in the beginning, I start with characters A, B, C, D, E.
So which models are using byte peer?
Uh,
Is there like
mostly.
they are using mostly
Yes, yes.
byte peer?
Okay. And that's why it splits to multiple items, small items. And it first gives this for example 0, 1, 2, 3, 4, 5. Then it counts, for example, first it starts to count how many times A and B comes to each other. For example, or TH, or blah blah blah. And then it sorts them. Once it's sorted, for example, then it's for example, I don't know, for example, cut at one million. I'm saying 1 million, 100. Then it counts the how many times A, B, and TH are coming next to each other. It builds up like this and comes down.
I see.
And then it cuts, it stops when it hits 15 now.
Okay, and that's obviously user determined max.
Yes, that is the model, who is training the model determined set. This is PPE. Word piece is the same scenario, but different. And it tries to understand, it's based on some logics to understand it, what order be the definition of the word.
I mean, mostly words, but not necessarily.
Yeah, not necessarily.
Well, I was wondering why there are all these different tokenizers. And for instance, I don't know did anyone try GPT style architecture with word piece, for instance, and does it really matter? So the performance changes a lot.
Let me answer you with language difference. For example, so at the end of the day, we do this also for what? We want to understand which combinations are quite important for us, right?
Yeah.
To learn a vector, to define a vector for it. Right? But if I come up with some bad stuff, that vector that will be assigned to something can be
Not used.
not useful even, right? In Turkish, it matters a lot. Like, imagine one item, 1 unit, happening in very different contexts. So the vector of it would be different should be different in different contexts, right? But we are assigning one vector for it, so we are asking the model to condense too much information.
So, I mean, I get these like contextual representations depending on, but the initial representation with these numbers, right? And how you parse the text into words versus these bytes, whatever pairings. That initial decision, I was wondering, like, what determines that just
like it is really like I remember from GPT there was a special piece of text that you were not able to feed the model. Because tokenizer was not able to digest it.
I see. So for instance, Chinese. So
That's
that's characteristic, like those characters.
It's very, and for that they have different tokenizers, different types of it. Like
But
even for
how do they do it in a multilingual model, like,
for multilingual model, if you take a look at, for example, llama and stuff like that, mostly how to say, they try to put Latin specific, like language next to each other mostly, and they avoid very different languages time to time.
Well, so they don't tokenize Chinese, but what do they translate? No,
They kind of how to say it. They have a tokenizer that kind of understands Chinese at the same time. As I said, it is byte. So here, when I said like A and B.
Okay, these are characters.
It's characters, but there it is 0, 1, 1, blah blah blah.
Oh, I see. For each one corresponds to a character.
It's this idea comes from very old times. It was a YPP was a simple computational algorithm.
I see.
So they use it.
Okay. Well, I didn't know. I mean, tokenizing is like, okay, yeah, that's obviously the first thing they do, and I mean, I wasn't thinking a lot about tokenizing and what role it really plays here.
Like imagine this, I have a text, but one tokenizer it splits down that is just characters. It's removed. So then, for example, for scientists, for science, okay, if your tokenizer assigns it for whole this thing you want, it makes sense. But what if your tokenizer split it all to S, C, I?
Yeah, that's not used. Yeah, it's important for sure.
Hocam bence herkes korktu gitti.
I'm excited all day,
I know.
lectures.
Hocam ders çok güzeldi.
Umarım ki iyi olsun.
Vallahi bayağı iyi bence. Şöyle. Eline sağlık.
Çok sağ olun. Hı? Pardon?
Sosyal medyada Türkiye kazanmak istedim. Bizim Özen Hoca yazmasını
Türkiye kendine gelir. Siz şey üstünde çalışıyor musunuz? Eğitim falan çalışıyor.
Evet.
Ortak çalışmak isterdim. Yani konuşuruz sonra. Yani her bir kafamda bir şey var.
Şu ana kadar yaptığım bir şey de var eğer. Nasıl hikayesi anlatıyorum. Reddit'te ben de bütün Reddit menüsü bir yerim. Türkiye'nin sıkıntı bence Türkiye sosyal medya sözü ve Türkiye'nin da bu hate speech olarak nasıl geçiyor diyorlar. Çalışma olarak da hate speech beslenenler. Cevap.
Ben bir tane farklı bir model çalışmam var. Yani kafamda var. Imagines. Cemal olsun. Yani sen farklı bir bizne kadar mı? Başka bir grupsun arkadaşlar. Tabii bu. Aslında like in that project. Biz öyleyiz. Yok ben başka şey için soruyorum. Ben kafamda başka bir şey. Ama arkadaşlar ben makalemi revizyona gelmiş bu hafta bitecek. Bitsin. Ben başka projem var. Çalışmak istiyorum. Hep konuşuyorum. Dersten sonra matematik hafta sonra atma. Yani hafta sonra ben bir bak. Dersim böyle ortak çalışmamızda böyle bir tane ileri yazı var. Hocam biz kayıt tarafından çalışıyoruz falan. Onu yani siz gelirse ben yapıyorum. Ki mesela özellikle tarafında konuşuyor çalışmak isteyen çok iyi bir ağırlık koyuyoruz. Nasıl geliyor? Nasıl geliyor? Orada bir orada çalışmak çıkar bence.
Şöyle benim hizmete zaten ondan önce danışman olarak yani çok mesela çok komik ve çok komik cevapları üzerine çalışıyorum. Alakalı şeyler olarak.
Ben bir proposal yazdım. Ona baktım böyle. Bilmiyorum belki biraz interest falan vardı. Şeyler demedi. Yani söz aldık belki böyle bir şey yapalım.
Şey göndermiş bir şeyler yapmış. Hep böyle
Oradan belki bir şey çıkardım.
Their brains are exploded, so they need brain.
As they wish. As they wish. Time, let's get back to, okay, one more time, let's get back to this pydantic thing. So model generates only text, okay, but we want something like, for example, Python would understand, or I don't know, any language, even R would understand. Okay, we normally use JSON for communication, stuff like that. And for doing so, I want a model, for example, to give me something like JSON, something similar to which looks like JSON. But model may not, for example, provide me this closing braces. Or it may put one, for example, I don't know, quotation mark, single quotation mark. For the other one, it may put, a double quotation marks. For those scenarios, so Pydantic handles those issues. So you do not to be be concerned about those scenarios. So that's why we use Pydantic. So this validate JSON does that. And if it was not successful, you can know that it was not successful. Then you would again pass your input to hopefully get something valid output. So you see, this is how a Python object looks like as an object. Like you see the sentiment, the name of the class, and also sentiment was positive, confidence was 95%, and rationale was the user explicitly states feels great after submitting the paper, indicating a positive emotional state. So you see the reasoning of model using the rationale like value. Why is this important? Why? Because hopefully we will talk in the next notebook. A simple task. There are some imaginary tweets. I asked the AI to generate these texts. So 9, I don't know, maybe 8 texts. And I just want to know, for example, the stance of the text, whether it is left, right, center, or non-political content. Now imagine I want, for example, use Gemini to do such classification. Actually, yes. Is it a good idea to use AI for tools like, let's say, Gemini for these? What do you think? To know the stance of a text. Anyone? Why?
Well, if we don't define the tense, it will depend on the prior knowledge that it has, but if it defines it, what
That is very valid. There is a paper showing that, but there is a bias between the models. Okay, like for example, if the model is like developed by a Chinese company, it like assigns a different kind of ideology or stances towards a text. Meanwhile, an American AI, which let's say Cloudy, assigns as something else. There is a very great paper that I guess a year ago they published. It's amazing that the way they studied. So it's just, I'm showing just one use case, but whether we should use it like this in our studies is your choice. You are the researcher. So let's say these are my tweets, a list of strings. Again, I define my output class. So there's a stance, there's a confidence, there's a rationale. Okay. My system prompt. So why there are these braces? Because if you put these parentheses in Python, and in every line, if you put these double quotations, you can have a multi-line text. It's like the whole thing is just one string. You're a careful political text coder. So look, I used the word coder. Why? I know that in social science, you use coders. We as computer scientists use labels. Okay? So it's a little bit different. Classify each tweet by ideological stance it expresses. Use non-political if the tweet has no political content. Keep the rationale to one short sentence. So one thing I would like to tell you guys, if you want to get a good high quality outputs from your model, always provide your instruction. Look, you're a careful political text coder first. Always have your like purpose in the beginning of the like prompt. Always. This is your instruction. Always. Then start giving context. Like classify each tweet by ideological. So this is my instruction. Use non-political. I am giving context. Keep the rational to one short sentence. So I'm giving like a little bit more context. Then provide like the tone you want, for example. Be very polite when you're answering. So provide your prompt, and then once you define all of those, provide your, for example, here our tweets at the end, always. So this is a really good study, like they have shown. Always have your instruction, have the context, have the tone, have the audience for whom you should generate this text, and the data. Or for example, here the tweets. Always. Keep that rational, like keep that in your mind. This is important. Again, the same like classify tweet. There's text, model, messages. We give system role, we give user role, temperature. Here, this time, tweet label, identity class. Then return tweet label that model validate JSON and provide the text. So for each of those, I run, like I iterate on each of those texts for tweet in tweets. I pass it to the function, get the label. I append to this list, empty list here, rows.append, like this. I use this asterisk label that model dump. It unpacks the dictionary. So this is this whole thing becomes a dictionary and it unpacks. So when you do this and you provide to PD that data frame this rows, it looks something like this. This is just plain how Python is. So if you know some Python, you would like give it to Cloudy, say please make it in a way that I could parse it to pandas, so it will help you. So this is the tweet. New infrastructure build will create thousands of blah blah blah. The answer was center. The confidence was 0.9, and rational. The prompt promotes an infrastructure build. So this is the output. This is non-political. Why? The weather in Berlin is beautiful today. It's non-political. It makes sense. So should we trust these? Should we trust the output of this model? No. To some extent, yes. There are papers that they're saying stop like doing like such kind of things that the analysis, the outputs of these LLMs are kind of in a way that we cannot really infer like, let's say, some causalities or things like that. So, and the way they conduct the research is this. Imagine you have 1 million articles and you build an LLM to, for instance, to code or annotate your articles, okay? So the way they conduct the research is they grab a sample of it, 10% of your corpus. You sit down, annotate, like in 3 people group, and then you say, okay, we did like quality check, we did the annotation. This is our, for example, validation set. Once you have it, then you say, for example, the accuracy of the model, the agreement scores, and you report these, and then say, okay, I'm happy with my model's output. Let's use the model now to do other things. Okay, so this is how they design the usage of LLMs in such research. So here, right now, I'm doing quick science check. So for one borderline text, look at this. Immigration policy should prioritize border security above all else. Okay. I am running it 5 times and I always get right. Okay. As an answer. And so here, yes, so model is self-consistent. If model is like sometimes given this, sometimes you're given this, we're asking like how we can do bootstrapping problem. Here's the issue. So sometimes, so if your model cannot really be reliable, then how can I really believe in it and then do other things? Right? Yes.
But here temperature is 0, right?
Yes, temperature is 0.
I mean, then you would expect these same answers.
Yes, but that's the thing. I'm saying that you should play with those temperatures, all of it, to come to this stage of self-consistency. That's why we set temperature to 0. Next is the second notebook. Here, I just talked in the previous one. Let me go up. In the previous one, I talked about some easy API calls. By the way, again, one more time, if you change the model ID to cloud or whatsoever, the same will work. Just provide the API key and things like that. The question, should we use local models, small models? If you don't have money, you have to. And how can we improve the performance of our local models? How can we know a small model will do the same job, for example, Gemini is doing? Okay, so for that, there are a lot of techniques. You can fine tune, you can play with the prompt, you can, I don't know, use the quantization methods, which there are a lot of options, but I'm not going through all of it because it's out of the honestly like context of this course, but I will talk about prompt engineering. Okay. There are concepts named zero-shot prompting, few-shot prompting, chain of thoughts, probably you've heard, and prompt chaining. There is tree of thoughts, another one, but a little bit advanced. I'm not going there. But all in all, the idea is let's help model with queries. Let's help model to provide us high quality answers. Let's get back to the same scenario. We import some things, Gemini API key, model name, defined in the call function. There are messages, response format, if we have a Pydantic response format, and the temperature, it returns something for us. Everything is the same like we had. I have created 10 fictional excerpts, like having these things. By the way, don't mind me, they may be not correct. I just used AI to generate these texts. Imagine this, that each of these is a news article you could scrape from a web page, or it can be anything, any kind of content, and for any kind of intents. And this becomes my data frame. I had a list, and right now it's a data frame. Each row is a text. Let's do zero shot. I just wanna, ask the model to say this is economically left or economic right or economic neutral. And culture also, is it a progressive or it is conservative or it is neutral? So I am providing my zero-shot system prompt, but what is the meaning of zero-shot? It means that I'm just asking my question, given my data, that's it. Okay, zero-shot, like we were doing previously in our not pre-result. But sometimes your task can be hard, really. Maybe sometimes you don't know even what it is exactly. You don't know your intention, really. But so if I ask someone what is economic neutral, is a little bit, even if you say left, it is hard. Sometimes you can define something with examples. You've seen people, like it is my, for example, strategy, where someone is asking me a question. I normally try to give deal breaker example, kind of like have a shortcut of avoiding the answering, just kind of giving an example, letting the person in front of me to understand the whole idea. Okay, maybe because I don't know the real answer, but that example helps. So for zero-shot setting, I define this prompt. You code political speech excerpts on 2 axes: economic, cultural, return only the codes. Okay. I give zero-shot system prompt here, the text and the format, Pydantic, and I just run for t in each of the samples. I pass it to this function called zero-shot. Model dump, I put all of the answers in the column zero-shot and df. This is the output. So for each text, I have a dictionary in each row here. Cool. There can be problems. So let's say you created that data, you sit down and annotate some examples, and then you check, you see that model is not working. The model is doing something, but it's not aligning. Look, remember this word, alignment. LLMs have alignment issues. So that is why we are trying to play with the prompts to align my understanding with LLM understanding. Okay. Maybe the black, for me, the meaning of the black color is different than what model understands. Okay. So that is the whole story. People are coming, let's align it, fine tuning, I don't know. Like in the beginning, you remember, like when GPT came out, ChatGPT came out, people were like asking, for example, generating toxic contents, but now it doesn't. Why? They aligned with our, they aligned the model with our morals. How? With fine tuning. Few shots. Let's see the example. I have the zero-shot prompt, you see here, plus examples. 1, 2, 3, 4. I provided 4 examples. It means 4 shot. Okay. But be careful to have it biased. What I mean, I'm sorry, not biased, balanced. Like if your answer is economic left, then there should be something right, 1, neutral 1, and like here we have 2 economic left. This is not a good idea, maybe. Try to have a balanced number of examples. Because why? Because when you have multiple examples from the same label, you're increasing the chance the model would say always economic left, economic left, economic. So that's one of the problems, you see. Again, you just play with the prompt, and then the same calling, the same interface. And now this is the few shot outputs, again appended to another column. So you should try to, when you're doing prompt engineering, you should start small, run on certain, let's say, number of samples, like we saw in active learning, basically the other day, Walid was talking active learning. So you start small, you run your model on that data, you see, and okay, these are good samples, you add it to your annotation data, you create another model. There is this equation, or basically human in the loop, you have heard, right? This is the human in the loop part. So you sit down, again, for prompt engineering, you check what to do, what to add, what not to add. But the main important part is the chain of thought. This really was a deal breaker. It really improved the performance of the models at the time. Very, very like significant improvement. Like in the normal scenario, I ask the output at once. Give me the label, okay? But I'm saying, hey, think. Don't answer me beforehand. Think. Tell me why something is something like that. Like I'm saying that, like normally we humans, what do? We like when I'm solving a question, I'm saying, okay, it is something like this. Because of that, this is something like that. Blah blah. It goes on and on and on. Then I reach to the final answer, right? So that is the idea. I'm asking the model to provide me the reasoning, 2-3 sentences, identify the economic cue, then the cultural cue. I am saying, hey, look, to get to the cultural cue, first, tell me the economic cue first. For example, I'm helping it to some extent because I'm saying there is a path from here to there. Use it, okay? Maybe your answer to that will help you to answer the other one. So for that reason, I add this reasoning part. Again, my labels, nothing changed, just add the reasoning. Same format, same outputs. Okay, now look at it. The text advocates for universal childcare, which implies public provision or significant state investment, aligning with the economic left principles. There are no explicit cultural cues related to the tradition, identity, or progressive social change, and blah, blah, blah. So it goes and then gives me the final output. You've seen when you are like on Cloudy or Gemini, when you write something, it goes to the thinking part. This is basically the same thing. They added this thinking token part. So they force the model to think, then come to the output. So again, the same idea. So when should we use the chain of thought? Ambiguous or multi-clause texts, okay? When you need to explain a code to to a reviewer or supervisor. So you want to analyze, to reason. You want when you want reasoning from the model, you want basically, because some tasks are quite hard to say, really, it is. Because sometimes the answer of your question is partially top left of the text, and then partially here, and then partially here. So it is hard for even a human to say the final answer, but when you want to be like reasoning, it goes through all of those steps and then it gives you the final answer. So that is why you should use the chain of thought in those situations. And when it is overkill, for example, what is the sentiment of the text? It's easy. Why should I use reasoning for it? You can get the help from the model for your own sake and the time that you are doing the prompt engineering. Just by adding is ambiguous. For example, here, you see this? You are kind of also saying, hey, give me a signal that then I'll go and check and then come back to my prompt engineering part to kind of fix. Okay. Honestly, I couldn't find any ambiguous situation for my texts because they were easy ones, but I'm 100% sure when you're dealing with the real world data, you will see all of those. So you go through it and then you have this is ambiguous flag. You can filter it, easy, take a look at the text and then tune your prompt. Prompt chaining. Prompt chaining is something that sometimes the task is so hard that one API call is not enough. One inference is not enough. So what I do is I basically make the API calls like something like plugin. I can like connect the thing together. And for example, sometimes a big prompt asks too much. You want to say, do this, give me that label, do that label as well. I mean, give me the sentiment. Also, go and check who is Barack Obama, and then go and get some news outlets from media bias, like, I don't know, BBC News. Go to the mediabiasfactcheck.com to check the domain of this, I don't know, this web news is, I don't know, is it like something like supporting Republicans or what? So whatever. It's a lot of things to ask. So you can then split your tasks and then chain them together. So let's say I split this thing into 3 sections. Extract the political claims from the text. First, I'm just saying, give me the political text claims. You can have a long text, political claims. Then I want them to be annotated one by one. Then I want you, once you have all of the results, give me the final answer. I defined 3 different but related pydantic codes. So first the claims, it's a list of strings. The field is just, I give a description for that. 1 political claim per item, empty list if none. Don't provide me anything if there is no empty, like political content inside. The second one is, look, claim, 1 claim. It is like a child of previous one, imagine. Then there, I want to label them economic, cultural. And the third one is, now I have, again, economic, cultural outputs from this one. I have here. I want confidence and some notes. Go on.
Those 3 are separate, right?
They are separate but related. We will do 3 API calls, yes. So stage A extract. So this is how I define a function. I use the call method we have beforehand. I have my system prompt extract each distinct political claim as separate string. Regarding your point, I am not defining any thingy like you are a political scientist or whatsoever. I'm just giving you the immediate task. And then this gets the text, returns me the list of claims, which we are cool. Stage B, each claim, I annotate each claim, okay. I also use the few-shot systems, a few-shot one, I have examples as well. I give the claim, I get the output, the second stage. And in the third stage, I have the text, I have the code claims, okay, cool. Give me the whole document code labels, whole, now, go do one by one, then aggregate for me. So stage C is the same thingy, but given a document and its coded claims, decide a single document level label. I broke it down, then I did collect it, and then I said annotated one by one. Then I am right now saying, give me the one final label, overall thingy. Of course, this will increase your API calls. You mean you will spend more money, but it's a trade-off, money and performance. So for chaining, you get the text, you get first claims, you pass it, then you iterate on each of it, you get their codes. Then you pass the text and all of the codes, and then you return the final answer. An example is this. Wealth tax on the richest 1% will fund the green transition our planet urgently needs. First, I got their claims. It returned the whole thing because it was just one claim. And in the second part, I'm iterating on each claim. This is for being generic, okay? This part, just maybe there were a lot of claims. I'm iterating. Here, there is just one. And like the claim here, this is the claim. And it is economic left and cultural progressive. Then I go to the stage 3, give the text, give the codes, and they'll get the final answer. Economic left, cultural progressive, confidence 1, notes. The document advocates for a wealth tax, which is economic left policy, and links it to a funding, a green transition, which aligns with the cultural progressive values. So, when to chain, when not. One clear coding decision per item, single prompt. Longer multi-topic documents chain. You need to inspect immediate steps. So the good thing is this, that you can quality check in each step what is happening. Like maybe one part of your whole prompt has a problem, so you can inspect. You can see what is going on, like why it is not working. Latency and cost matter, of course, single prompt, and for different stages and different models, of course, chaining. You can play with it. I have put it there. We have 30 minutes, right? Shall we have a 5 minutes break?
Sure.
Like just sit, like let's not go out. Because I just want to show something very fast.
5 minute break of what?
10 minutes break.
No, it's up to you. Like, we have to end at 5:30.
Okay, cool.
So what are we doing? Nothing.
Let's have a wait. Let's have a break, Hocam.
Okay, let's have a break. 3 minutes.
I just want to show the final paradigm, the state of the art thing they're using here. Other than that, you're good. You're good. Hocam okey misin? Halledebiliyor musun? Nasıl? Yeah, I will try. Okay, let's go. Let's continue. Here I'm gonna talk about agents. You probably heard a lot. Agentic AI, like they killed us with these words almost. Agentic, blah blah blah. And there are a lot of studies like agentic simulations. Like I've heard that apparently in the previous sessions you were like one of the instructors showed you one of those. And the thing is, what is the difference between a normal LLM call and the agent? So at the end of the day, we have an LLM, right? But what makes it that agent, and different than a normal model that we just give inputs? The thing is, a model's understanding about anything is static. We trained once model. Now we have the model, cool. But it just knows that, like it's over there. And what if I want to adopt myself with my needs, like with what I have in hand? Let's say I am the Amazon AI lead, and they comes to me, hey Ali, I want you to build me a chatbot, which basically is quite human friendly and talk with the customers asking, I don't know, like a brand's name, shoes, show those, try to persuade them to buy it. So let's say this. So if I ask a model like that, what are the Amazon shoes? It may say, I don't know. So I need to expose whatever I have in my company for that, right? So that it would be able to answer, right? That's one need. Context. This is the first need. Second, sometimes you have certain tools and you want to expose them, like what? Google search engine. You want the agent to be able to go and search on something on the internet and comes to you and answer. Okay, this is another need. 3, sometimes you want the model to be personalized, but you want the model to keep everything in mind, like a memory, and then continues. So, because if I ask the model, hi, how are you once, done. Another time, if I do an API call, hi, how are you, it won't say, you asked me earlier previously. It just says, just answers. So there's no memory in it. So I want to embed memory in whatever I have. So for that reasons, we need like agents. Okay. And it's nothing but just a loop. It's nothing but just a programming loop. There's a loop and there are iterations. That's it. Again, like in the code, you do some imports, you do some API key like settings, This is a good thing actually, like this is a good comparison. Steps, you just do one call in LLM call, in agent it can be many things. There is no state. There is no state in your LLM call. That was what I meant with the memory. Basically, LLM call is stateless, but agent can grow. Can take actions. LLM calls, no, but agent can. Via how? Via tools that I'm going to expose to it. Okay. Like search engine. I'm saying, hey, you can use the search engine. Go use it. Who decides what happens next? LLM call, you, agent itself. So when it does terminate LLM call, you get a reply and that is done. Like I asked the label of a text, it says something, like it's not non-political and done. But for agent, model decides when it is done. It continues until the final let's say condition is satisfied. So for LLM call, everything is text to text. For agent is while loop where the model is the condition and the body. So let's say this is my corpus. There is this corpus of text, okay? Some random text. Cool. Imagine this is my Amazon department. Amazon's, for example, certain products. It can be Amazon, for example, shoes. It can be a database of Trendyol's, for example, products. Cool. It's over there. I have this question. In the corpus, blah, blah, blah, I'm asking some question. I am asking this question from the model without providing anything about this. So when I do that, look at what model says. Unfortunately, I cannot directly answer your question about your specific corpus, blah, blah, blah. So it does not know anything about the corpus. So how can it answer? So for that reason, I create a tool. I want to create a tool that, hey, model, this is the tool. Go access that corpus, grab it, read it, and answer. So how can I do it? At the end of the day, a tool is nothing but a Python function. Look at this. Def list corpus. It just, provides returns whatever we had here, one by one. Whatever we had here, one by one. That's all. And I can use it and I can call it. It returns a list of strings. That's all. But for completion, look at what is right now changing. I have the model ID. I have my prompt, user prompt, and I have a list of tools. So what is the list of tools? Here it is a list corpus scheme. Why this is needed? Why we didn't provide list corpus itself here? Because in this schema, which basically why someone may ask why it looks like that? Because light LLM wants like that. Okay, it's the standard they are asking for. So here I am saying, look, this tool is a function. It's a Python function. Inside that, the name of the tool is list corpus. I provide a description. It returns the full corpus of political text with their integer IDs, and the parameters. So, what are the inputs of this tool? Nothing. Look, object, and it is nothing. It's empty. So, why this is needed? So, LLM will look at this. Okay, there is a function named list corpus, which is gonna return me this. So I will decide to use that. Okay, LLM will decide to use it first. It reasons. So let's run this. I run it. Okay, look at this. This time, the content is nothing. It didn't generate any text. But what it provided to me, I did message tool calls. It provided me a function. It's a very, very long text. So this is basically the function. So, and the index is 0. Use the first tool. Use the first thing, first tool you provided to me. Index is 0. So you could have had, I mean, a lot of tools. It could be search engine, it could be database access, it could be opening computer, I don't know, another software. It could be like, for example, in my social media like extension, I have an agent that it opens a browser and then loads everything, it clicks on the button. So every part of that is a tool, okay? So this is the agent loop. There is this while loop, for loop. I provide my prompt and tools. There's a response. And messages that append a reply. You remember I was saying it was a list? Why I'm doing this? Because I want to keep the history. Okay. If reply has no tool call, like there's no tool calling, just return the answer, final answer, the text. Okay. But if not, it will pass and it will come to this part. Use each of the tools in the reply one by one. And run tool, I give the tool call, okay, get the result, append to message. So once comes here, the second time it will have the query plus the answer of my tool, the output of my tool, and the next time it will provide me the answer, the final answer. So you remember? Let's go up. Here, this was my question. In the beginning, it didn't have access to any data, right? But it understood that it should go use the tool. It went and used the tool, got the tool's output. What is the tool's output? Basically, each of these texts, one by one. Then goes to the next iteration. This time, I have my question and all of my like corpus data there. This time, it will read the content and answer. So that's it. Like that is the whole thing. That is the whole fuss about agent AI. You define tools, you give access, and it shows what to use and where to go. That makes it not deterministic. And that is the problem we are right now dealing in this life, because everyone tried to make their companies AI powered. Let's use AI. They go and because every time they run, this agent goes does something different, and it is hard to control that. Because of that, we need human in the loop to do certain interventions and decide to like proceed or not. So this is the whole thingy, and this is the state of the art. Like nowadays, you see in ChatGPT, Cloudy, Gemini, there's an agent sitting over there. You ask something, for example, there are tons of tools they have defined for. For example, it goes, checks GitHub, clones a GitHub repo for you. Then code reading, there's a tool for it. It goes and reads the codes. Then, I don't know, it downloads an image from somewhere. I don't know. Then even you can define your own tools and expose it so it would use your tool. So then it moves to the concept of MCPs, and this is out of the context. But I'm just giving the word, maybe you were interested in, and you could take a look at it. So retrieval, computation, side effects, delegations. You can also run multiple agents at the same time for the same task. Get different outputs, then like aggregate the flow. To control the flow, it can go until infinite, like this tool calling. So you can put max steps, and you can stop it. Have you seen? Probably you used Cloud Code. You run it, then max. I don't know. You hit the, for example, your quota limit. That is this max step, something like that you see here. There is an ongoing field, privacy and research, let's say. and or risk evaluation scenarios. Like imagine this, the agent decides to delete your whole database. So how to avoid those scenarios is another like headache. So that's why you put approval gates. You can define your tool and then put also a text over there. This is very crazy decision you are making. Be careful, for example, or ask my approval. That's why when you're in your cloud code, you're asking, it says, do you give me permission to run this command or not? Like, so you give permissions one by one. And planning, you can do planning. You ask the model to plan the whole workflow and then goes do one by one as you approve. Safety I mentioned, and so on and so forth. So there's also a practice at the end of this notebook. You can define a tool, anything it can be. It can be just a tool, like you can define a tool like this, summation, Boolean summation. It gets two numbers, sum them up, and then returns the full sum. So it can be that, and then you can expose it to the agent LLM, give a description, then ask the model what is the sum of 5 and 10, and it will use that, pass the values to that, and then returns you the 15, for example, as the answer. So this is the whole idea of tool calling and agentic AI. That's it for me. I hope you liked it. I'm sorry that there were a lot of content or I couldn't convey my ideas in a good way to you guys. And that's it, Hocam. If there's any questions.
No, what is going to happen is this, we have this recorded, we have your collab notes as well. Most people are going to go back home after the institute ends, or even like back at the dorms, and try these out by adding like 100 liras or like $3 to their API keys, and then try it out with a full API key. And then
Of course.
Work through this line by line, and then your video is going to be the perfect guide when they go through every single one. So think of your lecture not as a lecture for right now, but for a lecture for the next 8 months for a lot of people. Do we have any questions? Do you have any criticisms?
Yeah, go on. That would be amazing for me.
It's okay, step by step, and why are we doing other
Yeah.
results? No.
I mean, I feel like this should have been like lecture number 1 before all of our like blah and so on.
This is totally empty right now.
The issue is, again, like this is completely a voluntary thing. Like people lecture here just because like they're part of our community. So it's always about like what can you do a lecture on? Which days are you free? What time slots are you free at? So we basically have people. So for every lecture that you see, there are about 4 other lecturers who couldn't make it due to time clashes or because they were busy. So it becomes kind of like beginner lecture is like on Wednesday, more advanced lecture is on day 1. So this happens quite regularly. What you do is that you like collect all of that information, codes and video lectures, and then do the actual sequential run after Summer Institute ends back from it. That's when you learn most actually.